Okay, so this talk is about a new method, a different method of governance of DAOs. And so what are some of the problems that are faced by DAOs? So one problem that is entrenchment. And what is that? So entrenchment is where we're supposed to have a decentralized governance, but we have actually large token holders. That's the first category, explicit control. We have large token holders or large delegates that in fact can have basically, they can have explicit control, obviously, if they have more than 50%, because they can win any vote. This is the authors of the next paper after lunch, among others, have documented this. So here is a paper from 2023. So what is this? So Nakamoto holders is the number of people that you need to get more than 50% of the vote. And if we look here, holders are token holders, okay? So, and then we also have delegates. We have two separate columns here. And in the paper, they note that if you take the minimum of these, you take the minimum of these two columns, either delegates, large delegates, or large holders, almost all of them are under 10, okay? So this is just this is an example of explicit control. Implicit control is where you get a lot of people are passive token holders, and actually a lot of delegates are passive. And so what you tend to get is a small group of active holders, and they do all the voting. They have effective control. This is also super well documented and even more striking. So what do we do to fix this? So we're going to create an auction-based control mechanism where if you win an auction, you can get temporary control of the DAO, but it's going to be contestable. You can always have a new auction, okay? And what this is going to create is it's also going to be sequential. It's going to create periods of temporary control where a single party has control, and then that control is going to expire, and then the DAO goes back to its default state, which is some governance state, usually voting. Okay, now one important feature is winning the auction does not depend on owning or controlling any tokens, okay? So this is very different from corporate control contests, which depend entirely on how many shares people own. And also another feature of this that's important is that empty voting has no influence. So many people in the room are probably already familiar with empty voting. So what is that? It's holding the voting rights in the tokens we're talking about here without having the economic rights. So how do you do that? Well, there's a whole lot of methods. Like, for example, this is familiar from the corporate setting. Like in the corporate setting, you can borrow shares. The lender retains the economic rights, but I can vote the shares. And we see when we have like proxy contests, we see massive borrowing of shares to do this. Whenever you have empty voting, there's another person on the other side who has what we can call hidden ownership. They actually have ownership of the economic rights, but we can't necessarily see that. Where does that happen? Where could that happen? A more obvious example is a swap. So somebody has some shares, okay? We're going to do a swap where we'll give them treasury bills in exchange for the economic return. We're going to swap the economic returns. So I'm sitting here, I have the economic returns, let's say from the token, but the person that ostensibly owns the token is different. So I've hidden my ownership. See that? I've hidden my ownership. And that's going to be an important piece, okay? So what is this method going to apply to? Well, this auction is going to depend on the market value of the token. So this is only going to work well for what I call economic DAOs, which is the governance token is publicly traded. The market capitalization of the token, in some sense, represents the value of the project. And this is kind of obvious for things like Maker, where if they do better in the system, the Maker governance tokens are more valuable. That's like a commercial project, but it's wider. Like you have a charity DAO, a social networking DAO. If they're doing a good job of what they do, the tokens are going to be more valuable. Okay. And one important point is often missed in looking at DAO governance. Many people think of DAO governance as if we're compared to a country. Okay, we have the government of a country. You know, you have like optimism, you have bicameral legislature, all this stuff, right? But countries are different because you have high moving costs. You're kind of, the people are kind of stuck there. But with DAOs, we can just trade the tokens and we can move almost costlessly. In economic terms, it's like having a T-bill equilibrium where we have no costs of moving between local governments, local areas. Okay, so that means that what we're really looking at, if we want to look at this normatively, is the community includes not just the people that have the tokens now, but people that could have the tokens. So we take control, we change how the DAO works, and the value goes up. It might be because we're getting other people that weren't currently token holders, okay? So what are the contexts and goals here? So there's getting rid of entrenchment, and this is gonna get rid of entrenchment, it's over, okay? But we also want to make this a really good mechanism for the DAO, potentially better than corporate mechanisms. Okay, so what are our two goals? We'd like to design the auction mechanism so that at any given time, we're gonna pick the best plan. We're gonna have the best business plan going forward for the DAO. That's one thing. The second thing, that's kind of obvious. The second thing, which is less obvious, is we want the surplus from that good business plan. What's a surplus? So the business plan is being executed by someone. There's a cost, and so we're going to take the kind of total surplus and subtract out the cost, and that's like a social surplus. We're going to try to send that all to the other token holders, and none to the person that's doing the innovation or doing the control. Okay. So why are we doing that? These other token holders we would call them Jensen-Mecklin free riders. They're sitting there, they have ownership in something, they're not making any effort. The control party is doing all the effort and spending all the cost. So think about this. How many people in this room are Jensen-Mecklin free riders in some investment? Like you have a stock, you have a crypto, and you're not really doing anything, you just own it. How many people are Jensen-Mecklin free riders? Should be everyone, okay? You know. All right, and so we're giving everything to you. We're gonna say we're gonna try to get the best projects, the best business plan. We're gonna take all the surplus and we're gonna give it to you. Isn't this great? Why are we doing that? We're free rider sounds like a terrible kind of thing, right? So it's doing something bad, okay? Well, the reason is simple, is that if we maximize the value that these other token holders get, the investment value of the DAO is gonna be the highest. Why? Let's go back to startup. We're at the startup point. If I envision in the future that all these innovations, we're going to find the best innovations and the token holders are going to get all the surplus, it's going to have the highest value at startup, right? Because I'm looking forward. That's true at any other point in time too. So it maximizes the investment value and it allows us to fund DAOs. We're seeing the whole potential of this DAO and we can get the most possible funding in the beginning. So those are the normative goals we're trying to do. So we're going to create some context here. So parties, a potential control party, a potential bidder in the auction, can implement a business plan. The price of the tokens at P0, 0 times 0. Initially, we're going to get a value V above P0. And then we're going to have some cost, C, okay? And so here's the social surplus. We have Q tokens altogether, so if we raise the token value to V from P0, multiply by Q, that's kind of the gross surplus, subtract out the cost, that's a social surplus. Any given party is going to have a best plan. We hypothesize V star, C star, which is going to give is the best they can do in creating social surplus. Okay, so all right, so how does the auction work? So a bid consists of three things. And I'm going to go to a picture here. I'm going to go back to this slide, but I'm going to go to a picture to explain this, okay? All right, so here's the picture. So what is the bid going to be? So here's our P0, the initial price. So one part of the bid is I'm going to claim that I can reach value V. I can reach some value above the current price. That's part one of the bid. Part two of the bid is I'm going to ask for part of the surplus R, okay? I'm going to ask for R. And then part three of the bid is if I already have tokens, I'm going to disclose my position. Okay, I'm going to disclose, that's this green part here. This green part represents the profit I'm expecting on tokens I already own. That's my total position. I have to tell you what that is. So why are we doing that? Well, because what do we want to maximize here? Now in this case, here's the cost to the bidder of doing the project. So in this case, all that's going to happen is between their profit on the toehold and the surplus they claim, they're just going to cover their cost. See that in the picture? Okay. So what are we doing? So this is the first best. We've gotten if this is the best project, this is going to be the first best because all the surplus, which is this white piece and this piece labeled F, this little white rectangle here, all the surplus is going to the other token holders. And we're basically going to create an auction mechanism where we're getting a bid based on that, or with an approximation of that. Okay, so let's go back to slide 5 again here. Whoops, I'm sorry, you need 6. 7, sorry. Okay, I'm further ahead than I thought. Okay, so what's the auction parameter here? This is what's going to determine who's going to win the auction. The higher this is, the better bid it is. So what is this? Okay, well, it's basically exactly, it's kind of what we described earlier. Let me just go to the picture again. Pictures are easier. So here's a more general case where this is not the first best. So what's the bid here? The bid is they're going to claim a reach of value V. They're going to make a surplus claim here, okay? And then the auction parameter is going to be this leftover piece, this piece, the white piece plus this gray piece, okay? That's the auction parameter. So what's going to happen in the auction? The winner of the auction is going to maximize the amount that's getting shifted to you, the Jensen Meckling free riders, okay, to the other token holders. That's how the auction works, okay? But there's also some other pieces here. There's deposits, okay? We're gonna require the bidder to make deposits. There's 2 deposits of value. There's actually more deposits, but these are the 2 we want to speak about. There's a value deposit. What's that? Okay, and there's a surety deposit. I'm going to describe each of these, but I'm going to use a picture again, okay? So let's go back to the picture. The value deposit is the entire top rectangle here, okay? We're going to make them deposit that entire amount. And here's what we're going to do. As we go along during the control period, if the token price rises on a sustained basis above P0, we're going to start refunding this deposit, okay? So if it rises halfway up, then we're going to refund half of that. So what are we doing here? Actually, this is it's mimicking an option. It's mimicking an option position. How is it doing that? So if what we're basically forcing, if we think of this as an option position, suppose you have a put, you have a put at V, and you have a short put down here at P0. So what's going to happen? Well, if we end up with some value down here, this is going to be a bear put spread, and you're going to get the gap between this, because you have a put at V, and you have a short put at P0. We're going to force the bidder to take the other side of that, to write that bear call spread, bear put spread, okay? And then what are you going to do? Well, as it goes up, as V is realized here, we're going to do what we would call, in option terms, we'd have knock-in and knockout put options. We're going to gradually pull that short put up, okay? So we're simulating an option position here. Why are we doing that? Because we want to make this mechanism code feasible. We do not want to have counterparties. So we're not going to force an actual option position. We're going to mimic the option position by having a deposit and having code rules, okay? So that's what we're doing, okay? So let's go back to 7. All right, then there's the other deposit, is surety deposit. I'm sorry, I should have left the slide up. What is that? Well, what we're doing in this auction mechanism is we're creating control that doesn't have to be accompanied by owning a majority of the tokens. In fact, it doesn't have to be accompanied by any token ownership, okay? So this is essentially, we're creating an empty voting scheme. We're creating an empty voting scheme where this person has voting control, the control party, but the ownership might not match with that at all. So what's the danger? I'm going to use the control to destroy value, maybe to destroy the DAO. So if I have if I have a small position, I get control, I buy a shitload, I buy a lot of puts. Okay, sorry about that language. I buy a lot of puts, and then I tank the DAO with my control, and I make money. So this is value destruction, and we want to stop that. So we're going to not only require this deposit here, but we're also going to require an additional deposit. And one simple version of this would be that these two deposits together add up to the entire pre-auction value of the DAO. Okay, what are we going to do? If you end up with a value lower than P0, we're going to dock you. Okay? So this is going to stop value destruction. That's the basic idea. Okay, so we're done with that slide. So now let's go to here. Okay, so let me just describe this again with the picture. So what does this look like? What are we doing here? Well, how are we going to do this? Okay, so what we're going to do is we're going to have a freeze out feature to implement this. So if this person wins the bid, wins the auction, they're going to be able to, we're going to force all the other token holders to sell a portion of their holdings at P0 to the winning bidder, and that's this part. That's a freeze out. Freeze out means we're forcing somebody to sell in a merger or something like that. We have a freeze out feature. We're forcing people to sell at a certain price. So we're forcing everyone to sell up a portion of their tokens at P0. That's a freeze out feature. Okay, and okay. So by the way, that's going to make this feature, amongst other things, is going to make this under current law probably impossible to implement in a corporate setting. And what does that mean? I was going to say we can kick their butt, but I'm going to say it anyway. The DAOs we can beat them out, okay? We can have Uniswap, which is already a better exchange, put some mechanism like this in. We have a better governance mechanism. It's going to create a higher value. We can beat the other people out. So this is getting better and better. You're getting all the surplus out here, and we're going to beat the regular corporate things. We don't have to diddle around with these little things trying to compete with minuscule trading fees. We don't have to do that. We can use this big club here. Okay, time is running on here. All right, so what are the properties? So properties, this is mechanism properties. You can read the paper if you want to look at this. So the mechanism is going to cause the bidder to reveal in their best project, they're going to reveal the token price they think they can reach. They're going to reveal V-star. It's a revelation principle. Part of that is being run by the value deposit. If they go over the value deposit, they bid more than that, that's not going to work because they can't reach that value and they're going to have to pay that money. So we're stopping them from overbidding to try to get a better auction parameter. Okay, it's an English auction. Now, one thing about this mechanism in the paper is I'm only making a claim in the paper that there is a kind of mechanism that would work. We could use different kinds of auctions. There's all kinds of other features. I talk about it in the paper that we could alter. But in this case, we have an English auction. That means we're probably going to end up here. We're going to end up here where we do incomplete surplus extraction. Because why? Because the winner wins at the second highest bidder's value. Okay, all right. So I'm running out of time here. Let me go back to, and let me just make sure we exhausted this. Okay, so the bottom line is we get the best project, probably, but there's going to be some leakage of surplus. And people that know game theory and auctions know that it's really hard to get full surplus extraction. There's only special conditions under which you can do that, and they don't apply here. Okay, so let's now, all right, so now we've already shown all these properties. We've gotten rid of entrenchment. We defeated empty voting. We've selected the best project going forward. We have a tendency to distribute the surplus to existing token holders, which maximizes the investment value. We've blocked value destruction. What else can we get? And we're running out of time, so we're just going to go through the list. Well, we have code feasibility. There's one tricky part, okay, which is how do you know that the person is not hiding part of their toehold over here? Okay. That's one of the hardest problems to solve. And it's actually really interesting. It goes back to talks yesterday, like privacy pools and things like that. How do we find out who these people are? And I could do that in the question period. It's a really interesting from the coding standpoint. It's the most interesting question. Implementing this, there are people interested in this. The best candidates are protocols that can solve this problem and that have tools to solve this problem. Okay, let's go back here. Now, this is an important part. We may care about voting. We may care about these other methods. They have participation values. Web3, there's all these values on, quote, democracy. So this mechanism allows the following. We also know that voting has a lot of weaknesses. There's a whole social choice set of weaknesses. What we can do with this mechanism is we can put our favorite voting thing in, which may raise the value of the DAO. If it goes badly, if it gets stuck, we can have a control period, reset it, start it again. We can also reform it, okay? The other thing about this is a lot of projects, like, for example, Maker, you read the Maker DAO white paper, what are we gonna do? We're starting out with the Maker Foundation, it's centralized, then we're gonna get to this idealized decentralization part, the Maker Foundation is gonna fade away. That happened, right? But then what happened? Well, it got re-centralized. Why? Because Ruin Christensen came back, had a big token share, re-centralized it, is trying to fix it. Okay, so that shows the problem of starting out centralized and going decentralized, and then that's the end of the world. A lot of times you're going to want to go back to centralized and fix the project, reorganize it. This allows you to do that using an auction. Okay, so I'm going to, there's a lot more to talk about, but I'm going to stop here because I'm already 2 minutes over time and have questions, or even better, if you have answers, like you have answers how we can fix this mechanism, I'd love to hear the answers. Okay.
I'm trying to figure out if this is bribe safe. Bribes are basically you're selling your right to vote to someone else, and they may have a different vested interest. So
okay,
this,
so let me
this
answer
is quite
question.
safe, right?
That's a good question. So first of all, votes don't matter anymore. The token, voting control is you have to win the auction. Now, but there's another part of this, which is collusion. We have a second price auction here, so we could have collusion, okay, and that is a problem. Potential collusion. What would collusion look like? So I'm the winner and bidder. I want to get the best possible amount of surplus. I want that second and third and fourth place person to collude with me. I'm going to give them part of the benefit. We're going to collude, and that's going to damage the mechanism because now you out there are not getting as much surplus as you could. That is a problem. We can solve that by having a first price auction and so on and so forth. So that's a place where bribery would be a problem here. I don't know if that didn't really answer your question, because if
you don't know how the purchaser of the bribe is going to act.
What?
Whoever purchases the bribe, the briber, you don't know how they're going to act.
The control party. We don't know how they're going to act, but they better act well. Oh. It reminds me of, like, I used to be a swimmer, and we used to have this imaginary thing where there's a bunch of sharks or something, and it's swim or die. Swim fast, okay? The party that wins this auction, if they screw up, first of all, if the value of the DAO goes down, they pay. If they don't reach the target, they pay. And look at this. People out there, suppose the person fails. They win the auction and they were just crazy. I mean, they failed. Guess who's going to get the value claim? You. Okay, so what is this? You're sitting out there. This is great. You're a passive holder. You don't have to worry whether the person succeeds or not. They succeed, your token goes up in value. If they fail, they pay you the deposit claim. You're sitting pretty out here. This whole thing is for you. This whole mechanism. Okay. Any other questions?
Hi. I think this is more going back to your motivation slide. I'm wondering, how is this different than saying some sort of standard like ERC20 gov tokens? I call that some standard with a land use tax. So think people in the room who are more economists, something like Georgism or like Harbinger tags.
This is Georgism.
So yeah, you're trying to like
This is it.
synthesize that, right?
Why is it Georgism? Because first of all, we're getting rid of a private property right. If this exists in the corporate setting, Zuckerberg cannot keep control of Meta. We can kick him out with an auction, okay? The private property right, if I can own a corporation and own the control, is over. What's replacing it? We have these bidders coming in. They're essentially renting. They're renting the company or the DAO. Why is it like George? George is, we have land, nobody owns the government owns the land, and everybody rents it. Now this is even more extreme. In the George things, we'd have a tax on the value of the land, but I can stay in my house. In this one, I can say, I like your house, I'm gonna pay more rent, bye. Okay, this is a pretty powerful, and this fits in, by the way, with a lot of Web3 ideas. A lot of Web3 people mention, like, and like Glenn Weil and stuff, they mentioned this, the George part.
Yeah, you might be interested in this. I don't remember the name of the project, but it's a series of pixels, and there was an ongoing auction. People essentially set their preference of when they get bought out, and so I think they decided to make some pattern on the 128 pixels.
Cool.
Each one's an NFT.
I'd like to find the reference for that.
Yeah, I can't remember the name now. Too many things.
All right, well, let's thank the speaker and take any additional questions over lunch.